Number 67. What is the pressure of CO2 in a mixture at equilibrium that contains 0.50 atm H2, 2.0 atm H2O, and 1.0 atm of CO at 990 degrees Celsius? Whoa. Okay, then they give us this equation. So the first thing I'm going to do is I'm just going to rewrite it a little bigger because we're going to work from it. And I noticed that there are no coefficients here. So while I'm doing this, I'm basically scanning the formula just to make sure that it is balanced. You could always, pause the video to get some balancing practice in. And we just always want to double check to make sure that, we're working with the balanced equation. But I'm looking at it here and this is already balanced. So next thing I'm going to do is I'm just going to write out the information that they gave me. So they told me that I had 0.5 atm H2. So that's over here. So I have 0.50 atm. They told me that I had 2.0 atm of H2O. That's over here. So I have 2.0 atm for H2O. And then I have 1.0 atm of CO. That's over here. 1.0 atm of CO. And we want to find out what that pressure of CO2 is, right? What's the pressure of CO2? This is the only one that they didn't give me information for. So I know that I need to find the ATM of CO2, right? The pressure. ATM stands for atmosphere. That is a unit for pressure. So anytime that you see ATM, you're talking about pressure. Okay, well, they gave me a KP, right? They told me that it was 1.6. So we're doing the KP formula. Now just make sure, guys, they did state that all of these numbers were at equilibrium, and that's super important because only equilibrium values are allowed in the KP expression. So we're good to go here, so let's write out that KP formula. Remember, the generalized KP formula is this. It's just the concentration of the products raised to the coefficients divided by the reactants. But only aqueous and gases are allowed. So always just check those states. But here they gave me all gases, so we're good to go. Let's write out that general formula. KP equals concentration of products divided by reactants. Or not concentration, because that's Kc, but the Kp, the pressures. So I have to write this in terms of P for pressure. So let's see, I got the pressure of H2O. Close that bracket up, and for all of them, there was one, right? For all of these, there was no number in front, which just means that I have one of them. So for all of these, you're going to raise it to the first, or you don't have to raise it at all, because anything that's raised to the first is the same, right? So now I'm going to multiply by the pressure of the CO. That's my other product. Close that up. Raise it to the first, but you don't have to. And now we come down to the reactants. I have the pressure of H2. Raise it to the first. I don't have to show that. And then pressure of CO2. Close that up. Beautiful. Now let's just put down what we know. They gave me the Kp value. They told me that it was 1.6. They gave me the H2O value. That's 2.0. They gave me the CO value, that was 1.0. They gave me the H2 value, 0.50, and we have to solve for this. So, let's get it going. 1.6, that's the Kp value, equals something over something else. Looks like we got 2.0 times the 1.0, so we know what number that's going to be on the top. And then divided by the 0.5, and then times x, right? This is the x value. That's the CO2. Now, what you can do is you can clean this up, or you could do cross multiplication. Do you see how this would be over 1? So if I just kind of smooch this over a little bit over here, you see how it's this times all of this, and then it's going to be these two times the 1, right? So I'm just going to do that in one shot just for the sake of the video. So let me just pull this up a little bit over here, and then let's see. At this point in time, try not to round because we're not at the final answer yet. So this one comes out to being a nice 0.8, and that's the x value. So 1.6 times 0.5 times x is 0.8, and then this equals, this would just be 2, right? Because 2 times 1 is 2. Divide by 0.8 on both sides. Cross this off, goodbye. And we have x, right? So x, and remember, x equaled the pressure of the CO2, right? We said that right here. X was the pressure of CO2. That's what we wanted, right? The ATM of CO2. So let's see. 2 divided by 0.8 is 2.5. And it looks like 2 sig figs all across the board. So there we go. 2.5, and that's ATM. And we are done. Look at that. The pressure of CO2, 2.5 ATM. That's the equilibrium pressure of CO2, and we're good to go. So hopefully this helped. Thank you so much for viewing the video. Subscribe to the channel if you want to help us out. That will helpfully grade us out. That will greatly help us out. Yikes. Anyway, thank you so much for tuning in, and I will see you all in later lessons. Bye-bye.